If you're a .NET developer and you think that IoT device development is not for you, you might want to think again. There are technologies and tools that will allow you to bring your .NET developer skills and full .NET to microcontrollers. One of these technologies is called Meadow. Scott Hanselman, the .NET developer, is joining me on the IoT Show, not just to geek around with IoT demos and devices, there's plenty of that, but also to discuss how modern developer tools and technologies will help mainstreaming IoT device development. Hey everyone, this is Olivier watching the IoT Show. We have a special guest today, Scott Hanselman. Scott, how are you?
I'm very well, sir. Thank you for having me.
Yeah, well, thanks for your time. And with you today, we want to talk about IoT and developers, or developers and IoT. I think developers is your realm. That's your job, in many ways, and you'll tell us a bit more about that in a second. And IoT is certainly something we've seen you playing around a lot. So first, Scott, who's Scott? For those who don't know you, who is Scott Hanselman?
So right now I'm the VP of Developer Community for Visual Studio, but really for Developer Division, right? So my job is to make sure that people are happy in the community with everything that happens out of the Developer Division at Microsoft. So that could be .NET or Java or Python or whatever, Visual Studio Code, and I also own the OSPO, the Open Source Programs Office, with Jeff Wilcox on my team. So I've got a whole team of folks that are excited about being developers and smoothing the way for the next gen of developers, or people who are moving into a new space, which is why I'm excited about IoT, because there's a lot of 10, 20-year developers that are maybe great web developers, great mobile developers that are not IoT developers, and I want to make sure that they have a good experience.
Awesome. And that's great, because we've been talking with other IoT experts, and we're all like old people these days, that there's a lack of understanding of what IoT is about and embedded development is about, but there is set of new tools and technologies, and we'll talk about Meadow as one example of them, that are coming up and are making IoT cool again, I would say, or more accessible. There is one thing I wanted to ask you before we jump into that, which is your interest into IoT. So like developers, no secret, open source, no secret, .NET, no secret. IoT per se. I know that if you do a search on the internet these days for the coolest IoT demo, chances are they'll find you doing a specific demo. So what is Scott's relationship with IoT? What kind of things have you been tinkering with, and how much do you like it?
Sure. Well, two ways to answer that. First, when I was a younger person, when I was a kid, I would always take apart objects, whether it be the toaster or later the thermostat or the remote control. So the idea that a physical object could affect the world, whether it be like a remote control that sends IR to a television, or a toaster, or later something like a thermostat that goes and talks to something, that became interesting to me. When I turned 20, though, I became a type 1 diabetic and immediately started creating objects, devices to solve my diabetes situation. I started by creating a Palm Pilot management system. So it wasn't formally an IoT device, it'd be more like a mobile device. But when you're diabetic, you are given a bunch of devices. You have your blood sugar meter, you have your insulin pump, you have these sensors and devices. And for many, many years, almost 20 years, they were not connected. They were occasionally connected. You would dump a CSV file from a meter. But now I have implanted a sugar sensor here. I have an insulin pump in my side right here, and those are all connected as IoT devices using Bluetooth and in some cases the internet to my blood sugar via an open source artificial pancreas. And when I did that connected demo many years ago, I was connecting the pancreas, the blood sugar meter, as well as the heart rate on my watch and Outlook, all into a system to try to figure out what the source of my stress was. And that was the point of that demo. But I've always been excited about that stuff, and being able to connect the physical and the virtual has been a passion of mine. And that's why I'm into IoT, because I am a connected device all the time.
You're a connected device. You created a digital twin of your pancreas in the cloud. And so basically early adopter and big fan of it. Would you say, so you're not the typical developer out there, right? You've been touching a lot of domains. Your career's been, a long one. Would you still say that IoT today is accessible to any type of developer, right? Because you talked about technologies that go from, C development on a device using Arduino or not, all the way up to cloud development. Can anyone do IoT these days from your perspective?
Yeah, 100%. I think we're in a funny place right now, and I want to juxtapose the whole AI ML craze. When people were data scientists in ML, it wasn't fun to say, and it was just a class of developer. You'd look at someone's LinkedIn, you go, oh, they're a data scientist. Oh, they're a machine learning specialist. But now AI has really good mouth feel. Oh, AI, I do AI, I'm doing AI, I'm doing artificial intelligence. It's the same people. It's still ML and data science experts. It wasn't fun to say embedded systems. It was actually a way of separating people. You had, like, there were web developers, and I'm an embedded systems developer. And we would go, ooh, embedded systems, that's scary, that's hard, that's low level. I could never be an embedded systems developer. But then IoT, the Internet of Things, became a thing. It's still embedded systems, but it's got good mouth feel. IoT and AI feels good in your mouth. It's exciting. That's an opportunity for us to get more people involved. Rather than saying, come down here into the embedded systems and do embed, that's very scary. Go, look, everybody can be an IoT developer. Everyone can grab an Arduino or a Meadow or a Raspberry Pi and start thinking about connecting stuff with the skills you already have. So I think that's what's exciting about this moment that we're in. And even though the branding is funny, IoT, embedded, AI, data science, the concept is there, and it's opened it up for everyone.
I like that. And we've seen the development of middleware's framework that are making it easier, right? Arduino is a good example, very well known now. There's this other thing that is called Meadow that is something that is coming from the .NET world. I remember .NET micro framework as being one of the infants or the ancestor of Meadow, I would say. Tell me a bit about Meadow and .NET for IoT. Is it something that you think will help make IoT more accessible, especially to developers that are listening to you, watching you a lot, which are .NET developers?
Yeah. So remembering, of course, that the folks who, watch your show probably understand the difference between a microprocessor and a microcontroller. But just as a brief reminder, here's a Raspberry Pi. It's a microprocessor. It runs a full operating system. I'm running Ubuntu on this thing. I can run video. There's a lot going on here. If I were to run one app, this would be too much. It would be overkill. So a microprocessor running one app would be overkill. But I could run .NET on this, and .NET is thought of as being a heavy industrial language that you would run on a PC or on a device that has some weight to it. This is a weighty device with 8 gigs of RAM. But if we look at the IoT platform that Meadow is built on here, this is, and we can actually go and look at the hardware for this. These dev kits are in fact microcontrollers. Okay, these microcontroller hardware are, and actually let me just zoom in on one of these here. Let's look at some of the form factor. These are tiny. You've got maybe 32 or maybe 64 megabytes, not gigabytes, but megabytes of RAM, but they're compatible with the mounts and the pinouts that we are expecting, and we can plug other devices in. They also have a fixed battery voltage, and they can run for potentially months. So the idea that if I were to run a device on a Raspberry Pi, the first thing I'd do would be get a big fat battery, put it in a backpack, and maybe I'll get a couple of days runtime. But with something like a Meadow, I might want to, create a weather control system. It's got to be waterproof. It's got to be industrial. I'm going to put it outside. It's got to sip power. So I've got a Meadow in here. I might want to talk cellular. I might want to talk Wi-Fi. I'm going to have all my sensors, whether it be wind or whatever, and plug it in. It's a totally different environment. Now, to say I could run C# and .NET in 32 megs is like, that's cognitive dissonance. It doesn't make any sense. People would assume that I want to run C, or I'm going to do something low level. But what they've done here, to your point, is they've taken these these open source libraries and built on top of it and invested on top of it. And they have the ability to do ahead of time compilation, compile your C#, and run it on a freaking microcontroller. So you don't deploy an OS, because the Meadow OS, the RTOS, the real-time operating system, is there already. You deploy your app entirely to the microcontroller and run your app. You boot into your app. Now, I'm oversimplifying things for our IoT enthusiasts, but from a .NET perspective, I just go into Visual Studio and I make an app like any other app. Isn't that crazy? Like, I can look at this and say, I'm a C# dev. I get it. You know what I mean? Like, there's an initialized task, there's events, there's classes like display controller, stuff like that. It's very welcoming. And I've been a web developer for 20 years, right? I don't know anything about embedded systems, but now I do. And that's really cool.
And Meadow allows you to bring the full .NET stack, or at least it will optimize what it compiles based on what you're using in your code. But it's I would say plain .NET in terms of the libraries you can use, right?
Oh yeah, like look at this. I didn't bring in some custom Meadow threading thing. I'm using system.threading, right? It is very intuitive. Like this right here is just some sample code. And if I may, I'm going to split to another screen here. That is running right now here, right? So I've got a Meadow device. I'll go ahead and zoom in there. And you can see it's got the temperature, it's got the humidity. Sorry about the focus. Focus is all, there we go. And like if I push on a button, you see where it says down and released. These are all events. You can see the light where it says lux and humidity. This is a Meadow project lab board. This code right here, if we switch back over into our code, is very intuitive. You look at this. If the right button, press started and press ended. Like these are just events. Anyone who knows how to do WPF or WinForms or even web forms is going to feel comfortable in an eventing environment. Even something as simple as the environment or the light sensor are simple events. Now they're taking care of abstracting that away. If you were doing this in C, it would not be evented. It would be in the middle of a big loop. You'd be watching for interrupts. It would be a lot less friendly and a lot more complicated. And then if you get into like the, let's look at the display as an example. We've got this display controller. Check this out. We can go into the display controller and we'll go into the definition of that. And we're just keeping properties like anything else for acceleration, for the state of the up button. It's not low level. It's just eventing. It feels like I'm on like almost like a mobile device, but it's a microcontroller, and that's nuts to me. That's just so accessible. And if that's going to get people excited about IoT, that'd be amazing. But this isn't a toy. It's actually in production.
Yep. Yeah, and there's two aspects to it. I was about to get to that part, but first another question before. I don't know how much you had time to dive into Meadow, but there's a couple of things that freak out embedded developers when it comes to having a middleware or a big framework like .NET with a garbage collector, with ways to abstract how the memory is managed, for example. And these are things that when you do embedded development, you're very careful about your memory allocation, about deallocating, about, your device is going to be in the field, not accessible. And so you cannot debug some memory issue, or even worse, some security threats. And so because it's compiled, if I understand things correctly with Meadow, it's compiled and optimized in machine code. And so that means that you don't have the mechanism of the garbage collector or the notion of resources that are still allocated and just vacant. It's something that is optimized for embedded by the folks at Wilderness Lab in their compilers, right?
Well, yes and no. So like it is still the full .NET core for all intents and purposes, and you can be less concerned about memory. You can't just go willy-nilly making memory. Like there's still the ability to run, all the things you expect to run, but also there's over-the-air updates, because you'd hate to get it wrong and then put it out in the field and then have to bring the device in. So you can actually ship an entirely new firmware, an entirely new OS, and an entirely new application build, like in the field. and they handle all of that for you. Because I think the question underneath your question is, updating these is a big difference from like going from a toy, prototyping board to going into production. And the difference between playing with this and putting this in my farm and never looking at it again and debugging it remotely and doing that kind of stuff is very, very, very different.
That makes sense. That makes sense. And Meadow actually comes with that cloud service that allows you to do these over-the-air updates and as plenty of APIs so you can integrate it into your application as well, right?
Yeah, that actually brings up a really good point, right? Because the IoT part, the internet part is always the back-end service. And whether it be REST APIs or whether it be protocols that are custom for IoT devices, you got to have something on the back end because these things are spitting out a ton of telemetry. And you have to think about how often is it going to be phoning home? What kind of data is it phoning home? What do those packets look like? You've got bandwidth issues. You've got power issues. Is it connected all the time? Does it go to sleep and then wake up every 5 minutes? All of those kinds of things are, in the case of Meadow, just as an example, are largely being handled for you because you can go and say, go to sleep for 5 minutes, wake up, check the sensors, put together the packets, send it off, and all the communications, whether they be the local communications like I2C and SPI and serial UARTs, or whether they be the networking things, are largely hidden from you, which is as they should be.
Yeah, as they should be. However, as a developer, you still have to think about these use cases or these constraints that you have, right? Because when you're developing, at the end of the day, actually, you might correct me, but what the perception, especially from embedded guys, that when you're a cloud developer, you can do whatever you want. You have infinite resources, infinite compute, infinite storage. It's not really the case because all of that has a cost, but still, you have more liberty in like doing or messing up or not paying attention. Good developers would pay attention to what they're doing and try to optimize their code. But even with Meadow and that abstraction of these complex layers, you have to pay attention to these use cases, to these constraints that you have on an IoT device.
Yeah, 100%. Like a real simple example would be is if you made a loop that said while true, and then, looked at the network or looked at the temperature or something, and then you said, wait 5 or something like that, that's going to be a tight loop and you're burning CPU. So on a Meadow device, you need to acknowledge that the platform exists. They're not hiding the platform from you. They're abstracting it away, but you need to say device.platformos.sleep, which actually will say to the Meadow device, bring it down into a complete low power draw, micro milliamps, and then wake up. And those sleep related events become important. You need to know just before I go to sleep, save some state. After I've woken up, do something. Those are not hidden from you. So you are not pretending like you're on a device with infinite compute in the cloud. You are on a tiny microcontroller, not a microprocessor.
That makes sense. One last one before I let you go, Scott. So you were playing around in VS Code. And that actually brings the question of how are the mainstream dev tools and technologies, and not just the IDE, but things like DevOps and so on. How do you think that will impact how people are doing IoT and embedded development? Do you think that's going to have an impact?
Yeah, I think it's huge because I think developers are selfish and we're lazy. And I mean that as a compliment. We're lazy because we want to do the least and make it work. And we're selfish because we expect a lot from our tools. So one of the reasons that I like talking about Meadow so much is that I'm a C# developer. I know C#. Meadow comes out, and suddenly I know how to do IoT. Yes, there are nuances, but I know. I'm like, I really wish I had a database. Well, there's no databases on IoT devices, right? Well, there are, in fact, SQLite database. You can use a SQLite database. Wait a second. I can have a SQLite database on a microcontroller? Okay, that's amazing. I want to also hit F5 and have interactive debugging. Well, you can't have interactive debugging on a microcontroller, can you? You can, in fact, and it's using Visual Studio. So in VS right here, I can actually hit F5 and I can connect to my Meadow devices. In this list right here, they'll show up as a COM port and do step-by-step interactive debugging within a actual physical device. This is a Project Lab V2. And actually, let me switch over and let's go full screen here real quick. So this is the Meadow device is just this right here. That's the feather, this thing that's the size of my thumb. You can actually see where you can pop it out. And this Project Lab board is all of the fun stuff with the sensors, the Grove sensors, the I2C, the power relays are all here. And then this is the Project Lab V2. This is the V3 with the larger screen. But the device itself, the Meadow, is just like barely the size of a finger. That's you prototype on this, and then you switch it and you go into production on something smaller. But here I'm plugged in with USB-C to my PC. And that's how I'll do the debugging. And that's how this app here was deployed from this Visual Studio project right up here. And in fact, if you go over to the GitHub folder for Wilderness Labs, you can go off into their portal. And all this stuff is all free. These sample projects are all over in this repository. And in the Wilderness Labs repository, they have a whole section about this what's called the Project Lab. The Project Lab is the board, and they've all these samples are all free. And check it out. Look at this. They got robots. They got Wi-Fi. And here's a great place to start would be a basic breadboard and a Maui app on a phone. You know what I mean? So then you've got the full life cycle. So think about how interesting that is. The idea that I'm a C# dev, I'm going to have a back end in C#. I'm going to have a front end in a Android device, and I'm going to have an intermediary with a sensor on the Meadow, and I can make them all talk together. I'm C# everywhere. I'm Visual Studio everywhere. I just think that's empowering.
And something you didn't mention, but which from my perspective is key, is that these are not just toys. You're talking about hardware that can be productized, that can be put into an actual industrial, enterprise medical device at the end of the day.
Yeah, so these devices, because they're so small and the chip itself is even tinier, like if you have the ability to go and control these boards and build them yourself, you could run, whether it be the weather example or a smart building or a smart farm or a tiny robot. If we look at this screen here, they've got so many examples: servos, logs, weather stations, graphics. I love this one here, the connected clock, opening things. Like literally the world is your oyster. It's so complete. You know what I mean? And it just really comes down to how much imagination you have, honestly. And that's what's so great about IoT.
Yep. No, I love that. It's the connection of the physical with the virtual world, and now open to all developers. For those who are Python developers, there's MicroPython. I've seen also some scripting with device create. There's Lua that is used as well by some people to do embedded development. So we're getting there.
I think about Meadow in the same context as I do with like MicroPython or CircuitPython, how fun that is. The idea that you plug a device in and you open up code.py and you start typing and you hit save and it runs. The fact that we have so much choice now in the IoT space is so amazing that anyone can sit down and do that. Make Code, Microsoft Make Code is a great place for kids to go and learn these things. And Adafruit would allow you to go and buy a small device and then plug it into your PC and start writing in Visual Studio Code. And then when you're ready to go and have your 14-year-old move into industrial IoT, you get them a Project Lab board, you teach them C#, and the next thing you know, they've made the great next IoT startup.
Awesome. I need to get you a t-shirt, IoT Rocks, or something like that.
Let's do it. I will wear it.
I'm sure you will. Scott, thanks a lot for your time today. I hope that our viewers, especially the ones who've never touched an IoT device, are now interested and will jump into that, because that might be the next step in their career, right?
Absolutely. Absolutely. You can do this. I have, you know me, I got all this stuff. I'm like, while I'm talking to you, I'm looking around on my desk for like sensors and widgets and light sensors and speakers and distance sensors and voltage change. Like, it's such a fun time to be an IoT developer. I'm actually working on this IoT connected Tony Stark heart from like Iron Man. You know what I mean? Like this, whatever you can imagine, you can do. And that's really, really exciting. Exciting.
For our next episode, we'll talk about AI on IoT, right? With TinyML. But that's That's it.
That's a whole other show.
Get excited.
TensorFlow, tiny. Oh my goodness. Yes.
We'll get you next time. Scott, thanks a lot for your time. And I hope to see you soon.
Thank you, sir.